Welcome to CIS110. Chapter 1 in your textbook is about computer hardware. And while it's probably easier for me to just show you pictures on Google, there's no substitute for being able to physically see this stuff, handle this stuff. A lot of people are intimidated whenever they think of motherboards and RAM and processors and things like that. But just understand that there are proper ways to handle it. But once you get the hang of it, there's really not much to it. Anyone could build their own computer at home using parts that they've bought without very little, probably I'd say in an hour at most. A couple of things I want to show you. If you're following along in your textbook, I'm going to try to break these videos up into small pieces so that it'll be a little bit easier to digest. The first couple of pieces of Chapter 1 is talking about what is a computer. Basically, think of a computer as a device that takes input from the user, processes that input. Basically, it turns everything into zeros and ones. On its core level, a computer operates on what's called the binary system. So it's zeros and ones. There's millions and millions of little switches inside the computer, and the switch is either on or the switch is off. When you flip these switches in sequence, you can ultimately get different things to happen. So the computer takes input from the user, processes that input, in some instances stores the input. It would store it on a flash drive or a hard drive or a CD drive or something like that, and then it gives output back to the user. Now this all happens so fast that it's almost impossible for us to imagine just how quickly it happens. If you are on your keyboard and you press the R key, you instantly see an R show up on your screen. All of those things actually happened between the time you pressed the R and the time the R showed up on the screen. It took the input, it processed the input, stored the input, in this case in RAM, and then put the output back onto the screen so you could see it. But I did want to show you a couple of parts and pieces of a computer. While it's not important that you understand and know every single part and piece and every single type of connector and the proper names of these connections and so forth, it is important that you understand like the basic lingo. Every computer, whether it's a Mac or a Windows, whether it's a laptop or a desktop, even the biggest servers in the world, all computers are basically made up of the same parts and pieces. You start off with what's known as the motherboard. Now, if you look at the pictures here that I'm showing on screen, there's lots of different motherboards. You have some that look like this and some like this. The color of the motherboard doesn't make any difference. What matters are the connections that are actually on the motherboard. Take this one for example here. This particular motherboard uses what's called an AMD processor. In this particular case, you can see that while it's kind of blurry, this is the CPU socket. The CPU, the central processing unit, the brain of the computer, basically sits down into this socket. There's pins on the CPU that plug into these little teeny holes right here on this socket. So that tells me it's an AMD style processor. When I go over here to this particular motherboard, there's a little guard, a little shield over it, but what you can't see underneath, there's actually pins on the motherboard. So Intel-based processors have no pins. They actually sit on pins that are on the motherboard. So the Intel processors are flat on the bottom. The AMD style processors, however, have pins on the processor that plug into the motherboard. You need to know these things whenever you get ready to go out and buy your parts and pieces to build your computer, because one of the things you need to know is, am I going to build an Intel-based computer or an AMD-based computer? Now, there's a huge debate as to which one's best. It's kind of like the Ford-Chevy debate. Intel is a faster processor and it has better cooling, but AMD is a cheaper priced, it's not a cheaper built, but it's a cheaper priced processor, and the speed can be just as good as an Intel. So, it's kind of 6 of one, half dozen of the other. The next thing is the actual processor itself. Now you'll notice in this particular instance, see how there's no pins on the processor itself. There's gold contacts, or actually copper contacts, but there's no actual pins. This is an Intel-based processor. There's no pins on the processor itself. When I scroll down and I look at this one, while we can't see the bottom of the processor, this is an AMD processor. This little green circuit board right here has pins on the bottom that plug into that socket that I showed you in the one previous. Now, processors generate a lot of heat. Basically, they have electricity flowing through them pretty much all the time, so they generate a lot of heat, and you need to dissipate that heat. Most of your newer processors, when you buy the processor, it will come with a heat sink and a fan. If your heat sink, which are these little metal fins here, if your heat sink has a fan built onto it, it's called an active heat sink. An active heat sink, there's an actual fan that is actively cooling. That fan will draw cool air into the sides of the fins and then blow it up out of the top. That metal fin thing here actually attaches to the CPU socket. There's a little dab of what's called thermal grease that bonds the CPU to the bottom of the heatsink. Now, in some cases, your heatsink doesn't have any motorized fans, like the case of this one. This is a really, really nice heatsink. It's copper. Copper dissipates heat better than aluminum, but you'll notice there's no fan that's on here that's blowing. These are called passive heat sinks. So, little vocabulary for you. Active heat sinks have fans built onto them. Passive heat sinks do not. Which one is better? It's a debate. For me, for my money, I'm going to buy the one that has the fan built into it. That way I'm sure I'm getting good cooling, but there's plenty of times when a passive heat sink will work just fine. This is the enemy of your computer. If anything is going to kill your computer faster than anything else, it's going to be heat. Heat is the enemy of your computer. So about once every 6 months, you need to take your computer and blow out all the dust. All this dust gets gunked up on the fan blades. It gets gunked up into parts and pieces. And think of dust as insulation. In your home, you have insulation in the walls that keeps the heat in the wintertime. Well, that dust is going to do the same thing. It's going to keep the heat in and not let your CPU heatsink operate as efficiently as it should. So every computer is going to have a motherboard. They're going to have a processor. They're also going to need RAM. Now, RAM comes in a bunch of different kinds, different flavors, different speeds, different price points. Some RAM, like these here, you can actually see the little circuits that are attached. Some RAM has these fancy heat spreaders that are attached to them. Doesn't really matter. One is just as good as the other. These are going to dissipate heat a little bit better, but one is just as good as the other. The key thing to remember with RAM, the more the better. If you're going to be using one of the newer computers, one of the Windows 7, Windows 8 computers, I advise you to get a minimum of 4 gigabytes of RAM, preferably 8 gigabytes. That's going to give you the best performance. Most of the time when people buy a computer and like 6 months or a year later, they're saying, oh, it's slow, I need to upgrade. Probably you could get by with just adding more RAM. The RAM is really, while the processor is the brains of the computer, the RAM is what really does the majority of the work. The speed that you see, like the experience that you use your computer, how fast it feels like it's operating, is really dependent upon your RAM. So the more RAM you can get from the start, the better off you're going to be. Now, this stuff is so easy to install. Don't pay anyone to install it. Instead, make sure you have the model and the brand name of your computer so you can make sure you buy the correct RAM, because not all RAM is the same. When you get ready to put your RAM in, you'll notice in this particular case there are little tabs on the edge. You pull the tabs back, put the RAM in. There's a notch, so it can only go in one way. When you push the RAM down, the little tabs snap back in and lock it in place. That's it. 5 seconds. Now, most people are going to charge you 30, 40, maybe even $50 to install RAM when it literally takes just a couple of seconds per stick. So every computer has a motherboard, a processor, every computer has RAM. You're going to have somewhere to store all of that data. The operating system, the personal data, the pictures, the music, whatever it happens to be. And that's where your hard drives come in. Hard drives comes, again, in all shapes and sizes, especially when it comes to like your laptops. Most of your laptops use a smaller hard drive, a 2.5-inch wide hard drive. Most of your desktops use a 3.5-inch wide hard drive. No difference, same mechanics, just smaller form factor. Hard drives are probably the most commonly replaced part on a computer simply because they have moving parts. Everything else in your computer, apart from the fan, everything else in your computer has no moving parts. The hard drive, however, has these little arms with these little actuators, this actuator here with these little arms that move back and forth across the platter. The hard drive is going to be moving constantly, and anytime you have moving parts and pieces, you have mechanical wear, and eventually a hard drive is going to go bad. I tell my students all the time, back up your data as often as possible, because it's not a matter of if, it's a matter of when your hard drive is going to die, and you never know. Sometimes it'll give you a warning, it'll click or it'll grind, and sometimes it just, you come into the office on a Monday morning and the computer won't boot, and therefore you know your hard drive is dead. So you have your hard drive. Hard drives come, it depends on what you're looking for. If you're going to be doing a lot of video and photos, you want a bigger hard drive. If you're going to be doing just standard email and like web surfing, a regular hard drive would work. Most computers nowadays come with some optical drive. Could be a DVD drive, could be a CD drive, could even be a Blu-ray drive. Doesn't really matter. These discs, whether it be a CD, a DVD, or a Blu-ray, these discs basically store data. They read movies. They let you take, whenever you buy a software application, you put the DVD or CD in the drive and it gets the data off of it, or it lets you burn data back to it. Inside of your computer, some computers have video cards or auxiliary cards, like a sound card, a video card, a network card, things like that. These are add-ons that you buy, or in most cases they come installed on the computer, but in some cases you buy them. You buy this particular card, you plug it into the motherboard, and it gives you expanded output. Typically video cards are the most popular upgrade. If you're a hardcore gamer, you're going to want a very high-end video card, something that has a really high refresh rate, awesome high-definition quality graphics. You're going to need a higher-end video card than the average person sending email and surfing the web. Now, if you're going to back up your computer, and I do recommend that you back up your computer at least once a week, if you're going to be backing up your computer, you may decide that you want to back it up on an external hard drive. Here's different examples of external hard drives. These, most of the time, plug into your computer via the USB port. This one is a small pocket-sized deal. Plug one end of the cable into the drive, the other end into the computer, and it shows up on your computer like a drive E or a drive R. Same thing if you're using a flash drive. When you plug your flash drive in, it's going to show up as a drive E or drive R, drive S, whatever it happens to be. External hard drives, like internal hard drives, basically come in all shapes and sizes. You can get the bigger ones that require wall outlet power. You can get the smaller ones that just use USB. The big difference here is speed. How fast of an external hard drive do you need? The faster ones are going to be able to back up the data quicker. The slower ones, you may have to do a backup overnight. I have my home computer set to back up once a week automatically during the night. So I don't care how fast my external hard drive is. When I go to bed, it's working. When I get up, it's done. No big deal. A lot of these external hard drives, when you buy them, they come with software that is backup software. So you can get that extra piece of software just for the price of the drive. They're relatively cheap. You can get these ranging from $50 all the way up to $200 or $300. When it comes to output, the output on your computer in most cases is going to show up on your monitor. Monitors, just like televisions, high definition, low definition, all shapes and sizes, all manufacturers. Any PC monitor, any computer monitor will work with practically any computer. You may have a weird connector that you have to buy an adapter for, but basically any monitor would work. Another form of output would be your printer. Now here are examples of inkjet printers. Epson, HP, Canon, they all make wonderful inkjet printers. As you probably know, if you have an inkjet printer, the cost of the ink is usually more than the cost of the actual printer. So I have found personally that I'll go to Walmart and I'll buy a $30 or $40 inkjet printer when they have them on sale. And when the printer runs out of ink, I'm better off to throw the whole thing away and just buy a new printer. However, if you have one of these really high-end printers, like this one, like a photo printer or something like that, you're probably going to be better off just to replace the ink. Ink cartridges run, anywhere from $10, $12 a piece to $30 or $40 a piece, depending. Here's an example of an older HP. This one has black, cyan, magenta, and yellow. I have had inkjet printers in the past that had 6 or 7 different inkjet cartridges inside of them. So it really just depends. These are things you need to consider. If cost is going to be a big issue, consider the cost of keeping the ink replaced, not just the cost of the printer. If you only print black and white, a laser printer will work just fine, and you can get those for under $100.